Hello everyone, I will give you a presentation about the Pac-Man project of team PacHero. In this project, we implemented two methods discussed in the lecture. The first is the classical planning using A-star algorithm, and the second is Q-learning. In the final submitted version, the agent is that using A-star performed better. I will introduce you the details of the two methods used in our project. First, you can see the features of Q-learning and its weights. At the beginning of the project, we set some initial features and weights. Then, as the number of games increased and the situation was dealt with, the weights were gradually adjusted. Now, all the descriptions and their weight values are displayed in the table of the slide. Since it is difficult to deal with the boundary problem and the noise distance using this method, and the performance of agents is not as good as A-star, we finally stop further optimization of the method. Next, we will move on to the A-star algorithm with decision tree approach. In this method, we implemented a heuristic which helps the Pac-Man to get rid of the ghost when attacking. As you can see, when the ghosts become closer to the Pac-Man, the value of heuristic will be larger and the Pac-Man will choose the way that far away from the ghost. When the capsule was eaten by the enemy, the defending agent will use the defensive heuristic to keep the distance with the enemy. The decision tree is used to tell the Pac-Man about its destination in different situations, and we clarified the specific strategies about the agents in the following demos. In order to find a better method to complete, we did some experiments and you can see the results now. In our test experiments, the agent using A-star performed better. It won 3 times while the agents using Q-learning only tied once, but both of them can beat baseline team at least. Now, we will talk about the challenges we met in this project. The biggest challenge is to create a decision tree. There are many conditions that need to be adjusted in the actual game, so it is also complicated. The second is how to use the noise distance and probability theory. We did try the Q-learning version, but it turns out that their benefits are much smaller than other factors. In addition, we list some possible improvements of our agents. At first, in Q-learning, it is very difficult to deal with the boundary problems and noisy distance, and we can also find a better balance between the reward weight of every feature. In the second method, we should find out a better way to protect the capsules when defending. What's more, we should avoid the situation that the Pac-Man will go into the dead end. Let's come into the demo part. We will talk about the specific strategies about the agent in this part. Our team is the red one. We set one agent for attacking while the other for defending. We talk about the defense agent firstly. In the beginning, the ghost will go to the boundary, and if there is no invader in the defending set, the ghost will try to eat the nearest food. And when the ghost eats 3 food stores or any invader appears in the defending set, the ghost will go home immediately. In addition, the ghost will go home once it observes the enemy ghost. What's more, if the ghost cannot observe the enemy but find any food dot was eaten, it will go to the dot which is closest to the eaten food in order to find the enemy. If the ghost can observe the invaders, it will chase the closest invader. Another strategy is that when the capsule was eaten by the invader, the ghost will keep distance with the invader and try to eat it after scared time. Next, we will talk about the attacking agent. At first, we set the target food dots into 2 types, safe food and dangerous food. Safe food are the food on the position where there are more than one direction to find a path. Go back to the middle line. Here are some samples. Then, if the Pac-Man doesn't observe any enemy defense or the scare time of the defender is bigger than 8, it will try to eat the dangerous food as much as possible and eat the safe food when there is no dangerous food. And when the Pac-Man observes the ghost, it will only eat the safe foods. However, when the score is lower than 0, the Pac-Man will go home at once when it is enough food to make the score become a positive number in order to win the game. And when the capsule is closer to Pac-Man rather than Ghost, the Pac-Man will try to eat the capsule first. And the attacker will go home when it is close to the middle line or only 2 food remain. What's more, the attack agent also tries to eat the enemy invaders in the particular situation. When this agent is located in the defending side and the invaders eat more than 3 food dots, it will chase the invaders with defending agent together. And here is the demo of the Q-learning approach. Two agents will use the value of feature times weight to find the foods. And this is all about our presentation. Thank you for your watching.